can people actually live on the moon? I don't mean just surviving inside a cramped, pressurized tin can for a few weeks, or taking a quick stroll to plant a flag and take a selfie. I mean truly living, establishing a permanent, self-sustaining civilization with streets, homes, schools, and a sense of community. For over half a century, we've looked at the moon as a desolate, gray wasteland, a temporary workplace much like Antarctica. A place where scientists and explorers go for a few months, endure the isolation, and pray for the day they return to the blue marble we call home. But as we stand in 2026, something is shifting in the global space race. We are moving beyond the era of visit and return. We are entering the era of stay and build. But the question remains, is the moon actually a viable home for humanity, or are we just pouring billions of dollars into a cold, dead rock? To understand the answer, we have to look past the dust and analyze the blueprint of our future survival. The modern conversation about space usually starts and ends with Mars. Thanks to visionaries like Elon Musk and companies like SpaceX, the red planet has become the buzzword of the century. We hear about moving 1 million tons of cargo and building a city of 1 million people. But as much as we love the dream of Mars, we need to be honest and look at the cold, hard logistical numbers that the hype often ignores. Mars is, by every definition, a logistical nightmare. The orbital alignment, the transfer window, to reach Mars only opens once every 26 months. If you miss that window, you are stuck. The journey itself takes 6 to 9 months of radiation-filled travel through deep space. If a critical component breaks on day 10 of your mission, there is no turning back, no quick rescue mission, and no emergency resupply plan. You are essentially on your own in a lethal outfit. Now, compare that to the moon. Our lunar neighbor is only 240,000 miles away. That is a mere 3-day trip. To put that in perspective, in the 18th century, it took longer to cross the Atlantic Ocean by boat than it takes a modern rocket to reach the lunar surface. If we need to move 1 million tons of cargo to the moon, we don't need 1,000 ships waiting for a planetary window that only opens every 2 years. We can use a fleet of starships making continuous shuttle runs every single week. If a colonist gets sick or a life support system fails, Earth is right there. The moon isn't a detour on the way to Mars, it is the essential gateway, the training ground where we learn to survive before we even think about the 7-month journey to the red planet. However, wanting to live on the moon is one thing, engineering survival against the laws of physics is another battle entirely. The moon is a land of brutal, unforgiving extremes. On Earth, our thick atmosphere acts as a blanket, trapping heat and shielding us from the sun's fury. The moon has no such luxury. During the lunar day, which lasts about 2 Earth weeks, temperatures skyrocket to 126 degrees Celsius, hot enough to boil water instantly. Then, the sun sets, and for the next 2 weeks, the temperature plunges to a staggering negative 175 degrees Celsius. These aren't just weather changes, they are existential threats to both human biology and silicon-based electronics. In science fiction movies, we always see beautiful, transparent glass domes covering lunar cities so people can look at the stars. In reality, a glass dome on the moon would be a death sentence. It provides zero protection against the constant rain of micrometeorites traveling at 20,000 miles per hour, and it offers no shield against the deadly cosmic radiation and solar flares that Earth's magnetic field usually deflects from us. So, how do we build a home there? The answer lies beneath the surface. We can harvest lunar regolith, the gray, powdery dust covering the surface, and mix it with binding agents to create a form of lunar concrete. By building our habitats inside lava tubes or covering them with 5 meters of regolith, we create a natural fortress. This thick layer of dust is an incredible thermal insulator and radiation shield. Inside these buried cities, the temperature remains constant, and the residents are safe from the sun's silent killers. But to truly call the moon home, we must break the umbilical cord to Earth. We cannot remain Earth-dependent forever. Shipping every liter of water, every kilogram of food, and every breath of oxygen from Earth is economically impossible in the long run. Fortunately, the moon is not as barren as it looks. The lunar surface is approximately 40% oxygen, but it is chemically trapped inside the rocks and minerals. Through a process called molten salt electrolysis, we can literally mine the air by heating the lunar soil to extract breathable oxygen. For water, we turn our eyes to the lunar South Pole, a place of eternal shadow. Deep, jagged craters there have not seen a single ray of sunlight in billions of years. Within those shadows, NASA and other agencies have confirmed the existence of billions of tons of water ice. This ice is the gold of the space age. It's our drinking water, it's our source of oxygen, and when split into hydrogen and oxygen, it becomes the high-energy rocket fuel that will power the next generation of spacecraft. Beyond basic survival, the moon offers something that could change the economy of the entire human race: helium-3. On Earth, helium-3 is incredibly rare, but on the moon, it has been accumulating for eons, delivered by the solar wind. This isotope is the holy grail of clean energy. Scientists believe that helium-3 could fuel the next generation of nuclear fusion reactors, providing limitless, safe energy with almost no radioactive waste. Just 100 kilograms of helium-3 could fuel the next generation of nuclear fusion reactors, providing limitless, safe energy with almost no radioactive waste. Just 100 kilograms of helium-3 could power a city the size of London or New York for an entire year. The moon is not just a place to live, it is the strategic energy hub that could power the entire human civilization for centuries to come. It turns the moon from a costly project into a profitable frontier. Despite all the technological solutions, the greatest mystery remains the human factor. Lunar gravity is only about 16% of Earth's. We know from long-term stays on the International Space Station that zero gravity causes muscles to atrophy and bones to lose density. But we have almost zero data on low gravity. Can a human child develop normally in 1/6th gravity? Can our hearts maintain their strength when they don't have to pump blood against Earth's heavy pull? This is the ultimate test. The moon serves as a biological laboratory. If we find that the human body can adapt to lunar gravity, then the entire solar system opens up to us. If not, we will have to develop rotating habitats to simulate Earth's gravity. But again, the moon's proximity is our safety net. If a biological crisis occurs, help is only 3 days away. On Mars, you are on your own for years, with no hope of a medical evacuation. Finally, we have to talk about the Space Race 2.0. This isn't just about NASA anymore. China, India, and private corporations like SpaceX and Blue Origin are all racing for a piece of the lunar South Pole. This raises a complex question: who owns the moon? While international treaties say no nation can claim sovereignty over celestial bodies, the first-come, first-served reality of resource extraction near water-rich craters will create the first true test of space law. Living on the moon will require more than just engineering, it will require a new form of global diplomacy. So, is the moon just a stepping stone, or is it the ultimate destination? When you factor in the logistical ease, the protection offered by regolith, the abundance of water ice, and the revolutionary potential of helium-3, the moon becomes the most logical place for humanity's first true city in the stars. It is the classroom where we will learn how to build, how to mine, and how to thrive in the vacuum. We are standing at the edge of the cosmic ocean, and the moon is the first shore. It's time we stop looking at it as a distant light in the sky and start seeing it for what it truly is, our first home away from home. This is the future of humanity. This is our real future, unveiled. The future is here. Like, subscribe, and join our journey to the stars.